Hello, everybody, and welcome to another episode of Learn with Jason. Today on the show, we have Eve Porcello, one of my favorite people in the tech community, one of the best teachers I've ever seen. Eve, welcome to the show.
Thanks so much for having me. This is very exciting to be here.
Yeah, it's I've been looking forward to having you on as a guest for I'm pretty much as long as I've been having guests, and we finally made the timing work, so I'm super excited. For those of us who aren't familiar with your work already, do you want to give us a little bit of a background?
Yeah, first
Thank
of
you,
many.
Eco.
Yeah, I work for Moon Highway. My husband, Alex Spinks, and I teach JavaScript courses to folks all over the world. We teach on LinkedIn Learning and Egghead.io, and then teach corporate classes as well. We've worked on some books too. So we've written a React and GraphQL book for O'Reilly, and we just really like JavaScript and Node and GraphQL a lot. So that's usually where you'll find us.
See, I'm finding, nope, that's not the right thing. Where's the book? Learning, is it Learning GraphQL?
Yeah.
Yeah. Okay. I'm posting a link in the chat
Nice.
for all to see. Well, cool. Yeah. So, and like, you're also an active speaker on this stuff. I've seen you give some really amazing talks. You're an egghead instructor. You're kind of all over the place, just teaching people how to do all like just really cool stuff in the GraphQL space. And now you're releasing more content in the React space, which is super exciting. So I guess maybe the big question that I see from a lot of people whenever I bring up GraphQL is why? Like and to make that a little more specific, what is the advantage that you get from using GraphQL that you don't already have when you're using a system like REST or whatever else you're using? I don't know what else people use.
Yeah,
So
I think GraphQL, the why of GraphQL, I'm not really here to force anyone to use GraphQL. I don't want to have you hate GraphQL and then I'm the person who represents what you don't like. But I have found a lot of joy in GraphQL because of what it gives us communication wise, because GraphQL schema is a really nice way to kind of bring everybody together, decide on what we want to build our app around. What are the types? What are the pieces of data that I actually need? It can become really tempting to have everybody go off and work on projects separately. And I think the schema gives us a really nice way of communicating about what we're actually trying to build. So it's like a nice sort of project planning tool.
mhm.
And then you can pull in your data from anywhere. So the reason why you might use it over REST is because not all data is easy to wrap with a REST API. We may have databases, we may have files, we have cloud services, all this data all over the place. And GraphQL gives us this nice layer over it so that we can get our data from anywhere, really. So that's why I think it's cool. But again, make your own decision.
No, and I'm pretty on board with that because I feel like the thing that really made GraphQL like the light go on for me with it was when I was working at IBM and we had so many different microservices, and there was this ongoing discussion where you would plan a project and one of the first to do items on that project was figure out who owns this data and get a map of what data is available.
Yeah.
And it was this really complicated process because we'd have to like kind of reverse engineer and figure out what the service was and then figure out where that was hosted. And then we learned which team was running it. And granted, like IBM's a huge company and this is a fairly extreme case, but you know, even that little bit of cognitive overhead of saying like, okay, who owns that REST API? Okay, let's send them a quick note and try to figure out what data they're exposing. That sucks. Whereas with GraphQL, it was like, okay, if all the data goes here, then I can just open this thing and open this docs tab and we can see all the data. And then I can right here just see what data is available and click buttons until I see what I'm getting back. And then I can write my app. And that in and of itself, just that one change cut weeks off of our project development times. And I thought that was that was when I became a believer, right? I was like, okay, this is the way that we can build front end apps on Teams without all of the pain, without that feeling that like teams don't communicate and because this kind of, it does the communication for you, which I love. I love that you said that about like the communication of GraphQL. Um, yeah. So quickly, thank you, Kaylee, for the sub. I really appreciate it. Ice Cream Tango. I know the boops are broken. I don't know what I did. I'm in the process of building something that I think is really cool for streaming, but I'm also like building it. It's like I'm putting the, I'm trying to put the wings on the plane as everything is in motion. So it's, it's held together with like bubblegum and best intentions at this point. So speaking of bubblegum and best intentions, we're going to build something from scratch today. So,
Oh yeah.
so Eve, what do you want to build today?
Well, here's the thing. I was watching our president be interviewed, and he was talking about this test that he took. It was sort of like a competency test. Now, I don't know too much in detail about it, but the way that you could say that you could prove that you're understanding what's going on is that you're able to retrieve data, specifically like a sequence of data. So what he said was that you're supposed to remember this sequence. So person, woman, man, camera, TV. And if you know that stuff, then you're recalling everything correctly and you're proving that you understand what's going on. So what I'm thinking is, like, as a teacher, I really want people to remember that they can get the data that they want from anywhere.
Okay.
So I think GraphQL is a really great tool for remembering those things. So maybe you can remember it: person, woman, man, camera, TV. That's what we're going to build today using GraphQL and Apollo server.
I'm so ready. Okay. All right. So let's switch over to this view here. And so first and foremost, make sure you go and follow Eve on Twitter for all sorts of funny content. Just like we're gonna build today. Okay, Ryan, thank you so much for the sub. I apologize, everybody. The boops are broken today. I'm trying to figure out why, but I'm not gonna get it done during this stream. So hopefully next week we'll be back up and running. Oh, thank you for the bits, Ishan. That's wonderful. And also we talked a little bit about Eve's book. Go and get a copy of that. Even Alex, and Alex was on the show before, so we have an episode. I need to get actual, there it is, on Apollo Federation, which is more GraphQL goodness. So, get in there for sure. Yeah, then let's see. Oh, one more thing. Let's talk a little bit about our sponsors. So today, the show is being live transcribed by White Coat Captioning. And thank you so much for being here and doing that for us. That is made possible through the generosity of our sponsors. We've got Netlify, Fauna, Sanity, and Auth0 all kicking in to make this show more accessible to more people, and we really appreciate that. So thank you so much. With that, Eve, you sent me a repo that we're gonna be using as a starting point here, and so this is the, let's see, oh yeah, the raffle yesterday. Let me pull up, or the Tuesday raffle, I should say. I will post those results in a minute. I got to look that up. So I will get to it before the end of the stream, but I gotta actually like find that. And I don't know where it went. Dashboard. No? Okay. So Eve, do you want to talk a little bit about this repo? And we can start digging into it, where I should start?
Sure. So basically the repo has a start branch and a finish branch. So if you want to jump ahead and look at that, if you want to spoil the ending, you can. But we'll be starting with the start. And basically what we're going to try to do today is we're going to try to build a GraphQL server that's going to pull data from multiple different sources. So we have so many different data sources where all of our data lives. And I think a lot of folks who are new to GraphQL think, well, we have to use one type of database, or we have to wrap one REST endpoint or something like that. When really you can use GraphQL to pull data from anywhere. And then GraphQL becomes this awesome like source of truth, location for knowledge that you can get all of your data in just one place. So yeah, I guess we can just clone the repo at the start branch, and
and I did that. to get us up and running here.
Nice.
So here is our repo, and we've got a live share going. So Eve is in here in case I get unruly and she needs to get me back in line. Okay, so let's take a look at what we got so far. We've got a README, and in a source directory, we have a couple markdown files. We have an index.js, and here's a person, and here are names of women.
Yes, those are my friends. They don't know that they're in this, but don't tell them. So basically, in the index file, that's where our Apollo server lives. It's kind of the starter for our project. Mm-hmm. If we think about what we need to get started with an Apollo server, it's really just our schema and the resolvers, like those functions that go get the data. So that's where we're going to start.
Nice. Okay. And then there's a little bit of feedback coming from your mic, like it's rubbing on something. Is it? Not sure.
Make sure. That's not cool. Be a professional. Oh, that's why. I'm not even.
Mike, how is that?
Oh, we are. I don't even know. If Guy Fieri was here, he said we just entered Flavor Town. It sounds so much better.
This terrible mic is just so that I can hear, but I'm really sorry about that.
No worries.
I've spoken into a microphone before, but it doesn't always go. I should do better.
No worries. No worries at all. No, I'm glad I said something because I didn't want to harass you about your mic and then be like, yeah, I know it's the only mic I have.
No, I have a real mic. I'm so sorry. Unprofessional. Get it together.
It's okay. Okay. So we have, so we want to get into our initial query and resolvers. And so we're looking at, I guess we should just talk a little bit about what we're working. So Apollo server is for serving Apollo or GraphQL. Okay. What is .env?
So the Apollo server part, Apollo server is one of the node servers that you can use to build a GraphQL API. .env is a package that's going to help us pipe in some environment variables that we'll set up because we're going to connect to a database, Mongo database, and we'll also be, I don't want to spoil other stuff we'll put in there, but okay. Anything that we don't really want to commit into a public repo is going to go in a .env file. So I'll have you can create it now or we can create it in a second. And that'll just go in the root of the project. Yep.
And it's already get ignored. Great. Yeah. And I have this cool thing installed where it'll mask so that we can set like this, and then whatever the value is doesn't show up. So we can actually add the environment variables and stuff on here, which is very nice. Cool. It's called Cloak. It's a VS Code extension.
Nice. For me, I just show everyone that stuff. I accidentally check database details into public repos all the time. So I just wrote that down so I use that properly.
This was such a problem for me that there's actually there's like a sound effect people can play when I show secrets.
Awesome.
Okay.
Yeah, sorry.
You hackers, you dirty hackers. Yep, there it is.
Exactly.
Okay, so we have then we have our type definitions, and this is the part that I really like about GraphQL because that's the whole thing, right? Like this is the thing that we're gonna get where we can make a query. It's gonna be called welcome, and we get back a string. And like there's some stuff to know here. Like you got to know what a query is. You got to know why this is here and why is that there?
Everyone in the audience should know, right? It's exciting. It's a question.
It?
No, I'm just joking. It just means that it just means that it is non-nullable. So it has to return a value. It can't return null. That's what that exclamation point is for.
Yes, and that is and so it can return an empty string, right, but it can't return the actual value null, right, which is important with data because I feel like there's a difference between we didn't get anything and it was explicitly set to empty.
Totally. Yeah, and everything in GraphQL is null kind of by default. We have to elect to add that exclamation mark to make it non-nullable. So there's we could talk for days about nullability in GraphQL, but we won't go too deep down that rabbit hole right now.
And so next, then we've got resolvers. And so I see a query here, I see a query here, I see welcome here, I see welcome here. What's going on here?
So the resolvers are functions that return data. So when we add something to the schema, we match it with the resolvers. And that literally, as we'll see, means it matches from whatever data you have. This is a simple example where we're dealing with a string and it returns a string. But this could mean that we're returning, I don't know, an array from a database, or we're returning a fetched REST API, all sorts of different things we can return there. So whatever we can do with JavaScript in those resolvers, in this case, you don't have to use JavaScript to work with GraphQL. As long as you're returning a match, it will work successfully.
Nice. So basically, as long as the return type matches what we're expecting, which is a string, then GraphQL's happy.
You got it. Yep.
Excellent. And to set this thing up, here's our start script. So we want a new server. We put in this typedef and resolver objects that we created up here. Tell it what port to use. Wow. Okay. So that makes sense to me. How do you feel, chat? You got any questions about what we've done so far? While we're waiting for the chat to think and type, what should we do next?
So next, have we started this yet?
We haven't. So let me do that. I will run an npm install. And I'm going to look up the start command. Start.
It is literally just start.
Okay, so my server's running at 4,000, which means I should be able to go to localhost 4,000. And here is our server. So we see the docs here. This is the thing that I love, right? So we're in queries. And so if I do a query, then I can just start to type welcome and it's going to autocomplete for me. And I can hit play and we get back hello. Now I can change this, right? Like if I go in here and just make this say something else. Look at that. So beautiful, right? We've got like, this is a GraphQL server. We did it. It took just a couple of lines of code. You know, we're at 30 lines of code total to build a working GraphQL server. Now, granted, this is like a really basic example, but I think it's important to point out how like at the base of it, there's not that much that goes into it. The rest of what's going to happen is like business logic, right? Like we're going to be figuring out, oh, I'm going to send in a variable, and based on that variable, I want to get this data. And that's not GraphQL anymore. Now it's just JavaScript or whatever programming language you're building your GraphQL server with.
Totally. And the playground that you see running on localhost 4000, that comes with Apollo server. There's some sort of in-browser query sending tool that comes with every server. And this is really nice if you wanted to host this locally for folks who aren't necessarily developers. If they need data, I used to be a project manager and I didn't really know too much about code, but I would send requests with Postman all day. And I'd be like, I don't know what's in these APIs. There's no documentation anywhere. So this becomes a really nice interface for actually knowing exactly what's going on, as you saw with the predictive text and the docs and the schema panel over there. It's good stuff.
Yeah. And like what I really love about a lot of this stuff too is like you could know nothing. You don't even need to know the first letter, and I can just hit option space, and it shows me everything that's available. Yeah. And that is really cool stuff.
Totally. Yeah, we're not here to memorize stuff. We're just here to get what we need.
Exactly. Like I think, that's something that I've been learning more and more as I've gotten further in my career, is that like my job isn't to remember things. My job is to know where to look for things. And I think that, we make the joke that senior devs are just people who know how to Google, but to a certain extent that's true. And really what you're doing is you're learning what questions should I ask, where should I look? And, because I can't remember anything off the top of my head. But I do remember sort of what, like, oh yeah, I've seen that before. It was kind of like this. I should Google this. And then I know, and then I find my answer. But okay, so I'm excited. Like, what do you want to do next?
Well, we say we don't have to remember anything, but we do want to remember person, woman, man, camera, TV. So let's start at the beginning. And we're going to create a type in our schema. So we'll start with person first. Okay. And actually, there's a little file called person.png, which is how all production ready projects look. You have a screenshot of a database record in it. Of course, this is very real world, but it is real world data. We got an ID, a username, we have a name, address, a birth date, and an email.
Okay.
So yeah, sorry.
If I move this over here, then we can just start putting, so do I need to put an ID in?
You do. Yeah. So we'll put the underscore ID.
So I'm just going to start putting in names.
Perfect.
Or like field names. And okay. So then how do we choose a type? Because like this one's pretty obvious. It's a string. But like what's an ID?
So if you're returning just a single value, which all of these seem to be, there are 5 scalar types. So there's an ID, a string, a Boolean, a float, and an int. I always get up in front of people and I like say there's 5 types and then I forget 3 of the 5, but I managed to figure those out today. So yeah, we basically, if we're not returning objects or arrays or more complex types, we're going to place those just after the colon there. So we need to decide which of those belong where. Unfortunately, our data is, it's not always going to have all 5. I should have made this return all 5, but that's okay. But the first one is kind of
seems reasonable.
Let's just throw an ID in there. Yeah.
So there's a question about Nikki is asking, what's the significance of the underscore? Is this a convention? Is this required?
So that's a really good question that I should have explained. The database that we're using, picture yourself, you're trying to build a GraphQL server to wrap your actual database, right? And we have some data somewhere about people in a Mongo database. So this is a database that uses Mongo, and that's how they decided to name the ID. There's always an underscore ID field. And oftentimes we create our own ID field that is a string, but in this case, it's an underscore. So that's just a Mongo thing.
Okay. And so username looks like a string.
Mm-hmm.
Name is a string. I'm making all these required. Should I make any of them nullable?
No, that's okay.
Okay.
We'll be really bossy with our people here.
Address looks like a string. Birth date looks like a different type. Do we need to do anything?
Let's just make that a type for now, or a string for now. We could make that a custom scalar, which is we would define the rules around what a date is. But for the purposes of our person right now, let's just keep that a string.
Okay, cool. What's up, Will? Good to see you. All right, hey, so this seems good to me. We've got a type. It matches up with the sample data we have here. Okay. So then the next thing that we need to do, because like right now, if I save this, it's going to break, right? Because there's no, it shows me a schema, but there's no like, nothing reaches it. I guess it doesn't break. It just like doesn't do anything.
Yeah. So, basically because our people are coming from a database, the next step is we need to actually set up that connection to the database inside of the server. And then from there, we can add our resolver because that'll be the easy part.
Okay. So to start, I want to do what?
So to start, if you take a look, you don't have to, but in the package JSON, there's a MongoDB import or NPM that we've installed. So
Mhm.
that's going to be what we use to set up our client. In other
Okay.
words, our connection to that database. So we can just import that. So the import is going to be called Mongo client with a capital M and a capital C. And then that'll require MongoDB
Okay.
and then dot Mongo client.
Got it.
Yeah. And then from
Collapse
there,
these.
yeah. Nice.
Okay. So I've got a Mongo client, and do I want it outside on its own, inside the start function?
You're going to want it inside of that start function.
Okay.
So that start function is an asynchronous function that's going to first make the connection to the database, and then we'll start the server. And
Okay.
then once we start, I'll talk about that in a second. Don't listen to me. What we actually want to do though is right underneath, on the next line, you'll add a URI, so const URI. And then we're going to pull that from our .m file. So it's going to be process.env and we'll make it all caps Mongo, MONGO underscore capital U, capital R, capital I.
Okay. And that means I'm going to need one of those in here.
Yes.
Mongo URI. And
so let me, I think I put it, yeah, I did. So yeah, the put DB info here thing,
Mhm.
I'll find that for you. I think I know what it is.
Okay. So I might pull this off screen for 1 second so we don't leak secrets.
And I also don't really care if you want to. Here.
Where did you put it?
Actually, I'm just going to paste it in that MD file. I don't really care if people see it. I just didn't want to break my working app if, because it is posted online. I'll show you that in a second.
Okay, so we've got
PW, all that stuff. Yeah.
Okay, so we drop that in. Apparently, cloak doesn't work when you extend beyond the. Oh, weird! It's because it's got extra parentheses and stuff in it. Maybe we need to quote that.
That's funny.
How about that? We'll quote it.
Yeah, that sounds good.
Okay, so we've got that. So now we've got an environment variable. So we've got our URI.
Mm-hmm.
And then, do I need to create like a DB or?
You'll create the client next. So you'll say const client, and then you'll await the Mongo client.connect. And then you'll pass the URI in there.
Okay. As like a, not in an object or anything?
Not in an object, yeah.
Okay.
And then you'll create another const db equals client.db. And then you'll call that because you're starting that connection.
Like this?
Yep.
Okay.
So yeah, that's what we need to do to get started with the database. So how do we make all of our server functions aware of that database connection? Well, we need to pass it via context. So we're going to create another function here. Right underneath, you'll add context there.
Okay.
And this is going to be, let's see, it'll be another async function.
Okay.
And this time we're going to create in a people variable, so const people. And then what we're doing is we're looking up what collection in Mongo that those people are in. So it's just db.collection, and the collection's called customers. So you'll pass that in there as a string. So
okay, so DB collection.
Yeah.
Customers.
You got it.
Okay.
And then what we want to return here is inside of that function is people. So it'll be an object with people inside of it.
Okay.
So.
Oh, an object with people inside of it. I understand.
Yeah. That sounds really weird, but you know what I mean, I think. Yikes. But yeah, that's what I meant. An object with people in it. Totally normal thing to say. All right. Okay. So we have our database connection hooked up. We have our context. Mm-hmm. What's next is we didn't write our resolvers. So let's go ahead and do that.
Okay. And then there's a question from the Stone Cold Man about modularizing this. So when we're writing out our types, how would you go about doing that? Like, is it just one giant schema file, or do you break these up? How would you go about that?
I think at some point you will probably want to break down your schema into smaller pieces. It's just natural that the schema, as it gets longer and longer, starts to become a little overwhelming. So there's a link in the chat as well about modularizing it into different files. You could do that by maybe type, or there's a lot of different strategies for dealing with that. But ultimately, you don't really want to start breaking things down until you need to. Mm-hmm. So I usually like to start with things as one document. And then if we get to a place where it's just too much to maintain, or a bunch of people are working together and it's just like, we have no clue what's going on here, then you can start to break it down.
I feel like that's a good, just kind of as a general programming truism. Like, if you start by putting everything in one place, then you don't have to open a million files to figure out where things are.
Totally.
And just, resist that modularization until you hit a point where it actually sucks to not be modular. Because otherwise I feel like it sucks to be modular when everything's tiny, right? Like if I have a million files with 8 lines of code each, I'm so upset.
Totally. 100%. And I think too, if you're thinking of a schema as a communication tool across all sorts of different types of roles in your organization, if people are like looking at things in different files, that's super stressful because you're going to miss stuff.
Yes.
So
yeah,
Linda said, don't make it too complicated to start. Sorry.
Exactly.
That's great.
Yeah. Okay. So, so we've got our person type, we've got our people data in the context. And so now we're ready to write a resolver. So where does one start with such a thing?
Where does one start? So basically, I'm thinking we want some sort of a query for a person. Okay. So I guess really we want to, instead of welcome, if we're doing things in an organized fashion, which I fail at a lot, we would create a person, and then we're going to return there a person.
Okay.
Let's also add some arguments to that person. So like right here, we'll say ID.
Okay.
ID, or actually username is what we want to do, because ID will be a nightmare.
Okay.
There we go. It's very hard not to type, but yeah, that's what we would do. So a GraphQL argument, think of that as just being like a filter that you can add so that you can just see the person we want by username.
Okay. And so now that we've changed the query in the type definition, I want to change it in the resolver. So I change it to person. And then do I just get that argument? Like, am I going to get username like this?
Yes and no. So every resolver has different arguments that are passed to it that we can use for different things. What I always do when I'm teaching is I say the first argument, I like to call it parent, but I'm not going to tell you what that is right now because I want to talk about the second argument. But it's up to everyone in the chat to keep me accountable and to explain that. So I'll just add a to-do here. Yell at Eve if she doesn't explain parent. Okay, that's an old joke, but I will say it again. So yeah, we'll use that. Remember, these resolver functions can retrieve data from anywhere. So if I choose Mongo as my database, then I will just use Mongo functions in order to access that data. So the first thing actually we need to do, I'm going to pop an async in here at the beginning of that function because we are going to be waiting potentially for that data for a second as it loads.
So this is cool though. So we can make our resolvers async.
Yes, you can. So
that feels like something that's a pretty big power up, I think.
Absolutely. So yeah, if our data is in Atlas, it's like Mongo's cloud database storage thing. I expect some latency in that process. Or if I was doing a fetch request, I would expect latency there. So yeah, you can use the friendly little async await or promises or whatever to handle data asynchronously in your resolvers.
Excellent. Okay. So we've got parent, which we haven't talked about yet. And then we get a second argument.
Yes. So the second argument is called args. So args is just anytime a user is searching for a person by their username, we're going to access it in that args object. So you can just add args there. The third argument is going to be context. Sorry.
To clarify, what you're saying is this here is whatever gets passed in here.
Big time. Yes.
Okay. That makes sense. So then this would be like, I would, if we make this into a actual function, I would be able to get username equals args username.
Yeah.
Okay. All right. I'm with you. And then you said the third one's called context.
Yeah.
Okay. And is that what we did here?
Yeah, exactly. So context is going to be this little container where I can put anything that our resolvers need to know. In this case, it's database details. So it's where to go look for that data. But it could be authorization tokens. It could be, just like anything your resolvers need in order to do lookups or anything like that.
Okay. And so then here I would be able to do like people. Wow, I cannot type. Here we go. Equals context dot people.
Yeah.
Okay. So this will always be the same in every resolver. The args will be different based on what query was called. So the args will match this. And then we'll talk about the parent in a minute. Are there any other arguments that we need to think about?
Oh, not today.
Okay.
There's one more called info, and that's for dangerous circumstances where you really want to do something wild with the schema, but we won't be walking that path today.
Danger and doing something wild is my middle name.
It's true. It could be really fun, but let's make this person work.
All right. Okay. Is the context function executed every time a resolver is executed?
If we are, I believe so. Yeah. Is that true?
I don't know. So I think what'll happen as you get deeper and deeper into GraphQL is that you will start finding ways to do things like batching queries or memoizing functions or things that, if it's always the same data, then you can make sure that only executes once. And there's a lot of stuff that you can do. To get started, don't think about that too much because it's going to perform well enough that it doesn't you'll know when you have a performance problem. And until you have one, don't stress about it. Okay. And then one other question from Nikki here is if resolvers can be async, does that mean you have to handle the promises async function return? I think GraphQL just does that for us, right? Like we don't have to do like a resolver.then or anything, right? It's going to take care of that.
Yeah. So that we'll take a look at in a second when we do the fetch, because that will, if we want to do any sort of data transformation or anything, we can. In the context of this one, no context, pun intended. That's not a pun. We would just use this Mongo function, and that's going to handle everything for us. So, So yeah, more on that in a little bit, Nikki, because we can use those thenable operators, which is sort of sweet if we like that sort of, if we love chaining, you don't have to stop doing it in GraphQL. So, so cool. Our person is right now returning, let's see. So all we need to do now is we need to call, let's see, people.find1.
People? Wow, why can't I spell the word people today? .find1.
It's a weird word. And then you're going to pass an object in there with the username. So we're going to look up the user by their username. Where does find1 come from? It just comes from Mongo. It's a function that's part of that library. So
I'm gonna, I'm going to link to the MongoDB package for anyone who wants to see more about how this works. They've got really good docs. So go and take a gander. And let's see, we're almost to that point. So, okay, so now we've got a person. Do I need to await this or anything?
Yeah.
Okay.
And then you'll just return the person.
Person. Okay. So then if I am correct and we haven't typoed anything, what'll happen is I'll be able to put someone's username in as an argument, and then we will get back a whole person object. So we'll be able to get all of this. So let's give this a shot. Do you know a username I can query for? Actually, let's just see what it does for me here. So I'm going to do my query. Cool. And I'm going to do the commands. I got to reload the page. Okay, there's person. All right. And then if I do a parentheses, it shows me username. Okay. And so what username should I query for?
Charles Hudson, all lowercase.
Okay. And then in here, we can choose what we want to get back. And so this, let's start by just getting everything, I guess. An address, here's a birth date and an email. And then if I run this, fingers crossed, drum roll. Beautiful. Look at that. That is gorgeous.
So lovely.
And like, so, but check this out. So now if all I needed was their, let's say their address, I already know their username. So I just need their address. Boom. That's it. That's all we got. Or like, I just need their email. Ah, gorgeous. So good. I love this. Okay. So we've got people, person.
Person.
So what's next? Woman?
You got it. You're really, you're killing it. This is so good. All right. So woman is next. We're going to, I was trying to think about what data to use for this. Oh, let me say one more thing. So we used a MongoDB, not to be repeating myself over and over again, but it's worth repeating that you can use any database you want. So if you like Postgres, if you like Fauna, if you like whatever you want to use, definitely use that. So moving on, email leaked. That's funny. This is just dummy data. So I don't think Dustin37 exists, but I definitely need to try to email him later.
Like, dear Dustin, I am so sorry.
I am sorry. My mic wasn't plugged in right. I put your email address. I'm really messing up on many levels. So what we want to do next is take a look at our women data source, because we want to find a woman. This is our next level of recall, is that we want to be able to pull a woman's information. It is funny to see people I know's names and they don't know. They're just going about their day. So basically what we want to do here is we want to use this JSON file to, create a new type.
Okay, so to create a new type, we've got ID first. Let me just pull this over to the right, and then we can look at both at the same time. There we go. Make this bigger. I'm going to hide the sidebar, and let's add type woman. And we have an ID, and that is going to be an ID. Or should we make it an int?
Let's just make it... Yeah, let's just make it an ID. That sounds good.
Okay. And then we've got first string, last string, and location string. Okay. So then up here, we probably want to do woman and woman. How do you want to query?
Let's search for them by their ID. So
Okay.
ID. Yeah.
Got it. And then we need to add one of these. Or we don't even need an async on this one, do we?
No, this is just straight up pulling from a file. So,
Okay, so this one's going to be parent, args, and we'll put it in the context, I assume.
yeah, we can. Sure.
Or I mean, you tell me. You're the boss.
Definitely not the boss. You're the boss. I need to pay respect. But yeah, we can put it in context, sure.
So yeah, let's see. A couple questions here. Ice Cream Tango says, when should we use extend type? Probably outside the context of what we're talking about today.
That's like the answer to every question I get. Some other time. Yeah, go ahead.
Do you have anything specific on extend type that we can link to? Like anything on Egghead or anything like that?
Yeah, definitely. So extend type just will help us put things in different files and helps us with a couple different things. I don't know that I have anything on Egghead about that, but I do have a blog about that. So or a project about that, not a blog.
Okay.
Should be a blog.
I'm gonna drop this one anyways because if you haven't watched the Egghead stuff, it is all fantastic. Where would I? Was it on Moon Highway? Do you think?
Hold on. I'm just sitting here like I can look it up too. I don't know what I'm doing. So it's schema.
There's an interfaces one.
I actually think so. I have this project about it. I don't know if I have an example. Let me share this repo that'll show you how to do it.
And while you're looking for that, DevChats asked, what's a content hub? In this context, a content hub is we're pulling in content from multiple places. So we've pulled in from MongoDB. We're about to pull in from JSON. And then we've got a few other places that we haven't gotten to yet that will be not MongoDB or JSON. So we'll have to kind of go through all of that. Should it be underscore ID? Lauren, actually, that doesn't matter. So the reason that we used underscore ID for person is because we wanted to match the MongoDB schema. So MongoDB uses underscore ID. In this case, we're not doing that. We're just using our JSON data, which means that we can match this format. So we kind of get whatever choice we want, right? It's up to us. And that's kind of the beauty and also a potential foot gun of GraphQL is that there are no rules. So you can do whatever you want, which means that you can be really, really flexible. It also means that if you don't have, if you don't have some conventions in your team, you can get really out there and like things can start to look very strange. But that being said,
Nope, I didn't find that thing. So I will look for it and I will share it somewhere. Why don't you drop me an email? I'll drop my email here. It's just eve@moonhighway.com and be like, Eve, you said you're going to do stuff and you didn't find it. So I'll find it when I have fewer windows open.
And if you want to go dig through, there are like a billion different great repositories here to go dig through for information. Okay, so let's get back to finding a woman. We have our data here. What we haven't done yet is pulled that data in. So how do you want to actually grab that? Where should we pull it from?
Let's just why don't we just require it and we'll just use it without context so that I want to make sure we show the fetch thing. So this will speed us up a little. If you add it to line 3, you can just say const women equals require, the file.
Okay. And then what we can do in here then is we'll skip the context and instead we'll get the ID equals args ID, and then we can return find cool, that should work. And then we can go up here, make sure that's right. Make sure that's right. Let's go do a query. And we will get ID 2, and we'll get first and last name. Oh no, cannot return null for non-nullable field query woman. What did I do wrong? I probably just screwed something up. Let's see.
Let's see.
Arg's ID. Passed in the ID.
Oh, we're looking for the username, not the ID. Or right? Oh no. Wait. Never scratch that. We are looking for the ID. What am I talking about?
Women find. And then we would get. That's right. ID. Is it doing it as a? Oh, you know what? I bet it's doing it as a string.
Oh yeah, get rid of that extra one. Our data could be better. I think probably. But that'll work.
I bet that solves it. There it is. Okay, so we could solve that a couple ways. We could go up here and say that this needs to be an int.
Yeah.
Right?
Which
and
is
then if I
probably
come
smart.
back here and we'll do triple equals again, and now when we pass in 2, it works. Okay. So that's, this is where typing is both very cool and also can be a little bit of a stumbling block if you're not familiar with it. But there we go. So person, woman. What's next? Person, woman, camera. No. I'm
leaving it up to you. We need to, this is why we have to build this. So
person, woman,
the next one is man.
Oh, okay.
So ridiculous. Cool. So the man, if you take a look at that, there's a file called data details.
Data details.
And this is literally a cheat sheet of nonsense. So I was trying to think of a man that I could fetch some data about, and I found this Ron Swanson quotes app, and I thought that was kind
excellent.
Of fun. So
I'm fully on board.
So kind of like an amazing thing about GraphQL that I still get very excited about is that you can just fetch from REST APIs using resolvers. So instead of having to go down a huge road of ripping down all your REST APIs and like having to start from scratch, you don't have to do that at all. Instead, you can just fetch, and that's a pretty cool thing.
Okay.
So
I pulled in these. Do I need to install like node fetch or anything?
Yeah. So in the dependencies, we should have had node fetch. So let's install that.
Okay.
I'm just gonna act like that was intentional. Definitely want to install node fetch.
Okay. So then I'm gonna go up here and I'm gonna grab it. Okay, so we've got fetch. We've got the stub of a man type and the stub of a man resolver.
Mm-hmm.
And so this is our setup here. So I can do const result equals await fetch.
Sure, yeah.
Like that?
Yep.
Okay. Then what?
And then we also need to make that function async, the man function.
Yes, we do.
So at this point, you can just say .then. So there's where that .then thing happens.
I'm gonna break this. Okay. And is this JSON?
Yeah, it is.
And this is just the regular old fetch API ported to Node. This is an amazing API. If you are not using it and you're using something like Axios, I would highly recommend looking at this one instead because it's built into the browser, and on Node it's teeny tiny. So it's going to drop your bundle size and it gives you all the same features and benefits of something like Axios.
Totally. So at this point, if Actually, you want to pull up that URL in your browser just so we can take a look at it. The Ron Swanson thing.
Okay.
So what this returns, is an array with a random quote in it.
Okay.
So it's pretty simple. Every time we hit that route, we're going to return a random quote. So that's really what we're going to try to model with our data. We're just trying to return that quote.
Okay. So then here, we can do something like this.
Yeah.
And then return that quote. And all I'm doing here is destructuring. So I'm just getting the first element of the array, and then I'm going to return that straight up. So then this is going to be quote, and that'll be a string. And that should be that. Let's try it.
Nice.
Oh no, I got to start the server.
That's what I get for not installing Node Fetch with the
man, but not in schema. Oh, I forgot to define the query is why.
The query, yeah.
Okay. So then we're going to have man, and that returns a string. Try again. There we go. And we'll do man. There we go.
That's a particularly funny one.
That's good.
Nice. So that's our quote. But I wanted to keep it simple with our fetch request, but just know that if there's any data you need to get from anywhere, this is really good for like content APIs. So if your content API has some sort of REST endpoint that you need to pull data in from, you can bake that into your schema and just use the fetch as a simple way of getting that data. Pretty cool.
Like this is super powerful. Like I love this as an approach where you're like, oh, I need to use a REST API. Great, hit it.
Yeah. Somebody had asked in the chat too, is there a performance penalty when fetching from another API through your resolver rather than just querying it directly? So yeah, I mean, if you are wrapping REST APIs with GraphQL, you still are making that HTTP request to another API. So that's a nice transition. Taylor, it's like I planted you there to ask that question, because there's a pretty cool tool from Apollo that we can use to make performance even better with these fetch calls. So that's next.
What up? What are we doing?
So next, we are going to, everyone has been waiting for this. We're going to use the Best Buy API, and just like we all thought we were going to today, and we're going to create a wrapper around this REST API. So yeah, let me slow down and let's go take a look at the docs. Very, very normal app that we're building. So I was trying to figure out where to pull data from about cameras and TVs, and Best Buy has some really nice documentation about that. So there's a product API and a category API and all these stores. So I don't know, you could build something cool with this. Yeah. I did have to request a token from Best Buy, and it rate limits me a lot, so it probably will do the same to us, but it'll work. We just have to hit it a few times and it'll like start working. So kind of fun. So yeah, we're basically just going to try to find a camera, and then a TV, and then we're going to pull it from this REST API. So they have pretty nice documentation about it, but I have dug through this and put together those links in that file called data something that I made, data details.
Okay. So here's our whole thing, which means we're going to need one of these. So I'll go here, and then we'll have to drop that in. Yeah. Do you want, let me pull off screen, and then you can drop it in that env.md and I'll pull it out.
Okay, cool. And of course, I totally lost my API key. Let me find it. So there we go.
Where are you? I just lost
I'm
you.
back. I'm back. I think, right?
I don't know. I don't see you.
Oh man.
Did the live share break? Where are you? I see you in the index.js.
Okay, I'm coming back. I guess I'll have to look at the link again. In the meantime, while I'm struggling with that, basically what we're going to try to do is, have you looked at Apollo REST data sources before?
Apollo REST data sources. I have not.
So this is me stalling, but it's for a purpose where basically, I'm just going to drop that in the index because, or wait. So Apollo REST data sources are what we're going to use to wrap two different REST APIs. So we're basically going to create this GraphQL wrapper around the Best Buy API.
Okay.
And why would you do this versus using Fetch? Well, it's kind of what Taylor was talking about. We want to use Apollo REST data sources because they're going to help us handle caching and deduplication of our requests and things like this. So it gives us a nice little cache locally that we can work with.
Okay.
In order to, if I request the data and then I request it again, I can look at the cache versus going directly to make that HTTP request. So
okay,
that's what that's all about. I'm going to drop in that key in the index.js file because I don't care about security.
And I'm dropping it into the .env file, and we're back. Okay, so I have the Best Buy API key stored here, which means that we need to let's see. I need to install that Apollo data source REST, right?
Yeah.
Oh, that one's already installed, so
cool.
We can grab that from. Let's look at the docs. It says REST data source from the require. Okay, so
yeah,
REST data source equals require Apollo data source REST. Good. And then what do I do from here?
So from here, we're going to create it. So if we scroll down kind of above where we create our server, above that start function.
Above, like here?
Yeah.
Okay.
So like 68 around there. We're going to create a class that wraps the REST API. So it'll be called class Best Buy API or whatever we want to call it. Extends REST data source.
Okay.
And then in the constructor, we will call super. And then I'm going to paste in this link for us because making you do so is too rude. And this is kind of the base URL. It's like everything after that will specify which products we want. But for any request, it'll always have that main beginning of the URL, basically. Now, once we've created this, we're going to create a function, and it'll be an async function that's just going to be in charge of getting the data. So we'll call it async get data.
Async get data. Yeah, I haven't written classes in JavaScript in a very long time.
It's kind of oddball, but fun to fun to think about it that way. So we're going to actually let's just call it get camera. I shouldn't have called it get data.
Okay.
So now inside of this, we're going to use those long URLs that I pasted. Let me just help us with this. We're going to const camera.
Okay.
And what this will do is we're going to call this get function, and we're going to get a specific route. So I'll type this out so that it doesn't look like I'm copying and pasting too much, but I don't want to make you do it because I am a guest here and I should be polite. So what we're going to do is I made it like 4 characters. I'm pasting this baby in. There we go. So this is a very long URL that is upsetting, but ultimately it will get us the data that we want, which is cool. Yeah. So if we hit save on that, that will be too long of a URL for anyone to actually read. But we have a couple interesting things going on there. So we have the category path name. So that's going to give us digital cameras.
Okay.
We're learning a lot about the Best Buy API today.
Getting it back in JSON.
Uh-huh.
And then we're picking our fields here.
Yeah. So we're deciding, there's more than that, but that'll kind of give us what we need. We actually don't even need that description because I think that's been deprecated. So that's a whole other thing.
Okay.
I've also added this sort by. So where does sort by come from? That's actually going to come from our arguments. So
Okay.
the arguments are going to be passed into that get, what is it called? Get camera function.
So like as an object?
It's actually just as a value. So we don't need the braces.
All right. And then we've got our Best Buy API key, which is set in .env.
Right.
Okay.
So then we're going to say then we'll take in the data and we'll return data.products.
Okay.
0. So we only want one product. We want one camera, right? Because that's what we're doing. And then we can return the camera.
And so the get is like a wrapper around the fetch API that does extra stuff for us. So like we don't have to run the response.json or any of those things. And if we run this more than once, it's going to cache that response.
Yes, absolutely.
Cool.
So
okay.
Yeah, it's pretty cool.
So then we can return the camera. And then do we want to add this to context?
We do. So we'll add it to context. Well, it's actually going to be another key on our, on our server. So right underneath the context there, we'll say data sources. Now data sources returns or is set to a function. So data sources : function, or you were right too. And then we'll say we want to return, actually we're returning this object. So I'm going to sneak in here and we want to wrap this because we're returning an object. I feel like this is the source of many JavaScript bugs. When we're returning an object, we want to make sure it's wrapped in parentheses. And then what we're doing here is we're setting the Best Buy API to a new instance of the Best Buy API. There we go.
Okay. And so now if I go up here to types, I'm going to add type camera. And I believe our fields were SKU, name, sale price, description. So I'm going to grab those.
Cool.
And then are they all strings?
Everything except the sale price, which is a float.
Okay. Float and string. Okay. And then in the query, we want to add camera. And this is just going to be like no arguments, right? Or no, we wanted the sort by.
Yeah. So what we could do is we could say sort by, and then we could use something like a sort category. And that's a good place for a GraphQL enumeration type. So it's kind of like a restricted list of options for a field.
Like sort category like this?
Yeah. Exactly.
Here we go.
Nice. So then typically we'll just say like, let's do 2 of them. SKU, all caps. That's more of a convention than a rule that we want to capitalize those. And then the next one is name.
Okay. And so then this would be sort category, and we're going to get back a camera.
Yeah.
Okay. Cool. And then that means in our resolver, we need a camera resolver. We're going to get our parent, and then we'll get our args. And where does the data source come in? Is it in context now?
It is in context now.
Ooh,
yeah.
Magic.
So
Okay.
magic.
Okay.
It's not going to go in another argument type, but adding it to the server constructor will put it there.
Okay.
Wild.
I'm making the assumption that this needs to be async. Is that correct?
That is a correct assumption. Yeah.
Okay. Then I'm going to pull my sort by out of the args sort by. And then we want to return context best by API, right?
Yeah. So it's context.datasources.best by API. Yeah. So we'll just sneak data sources in there.
Get camera, and we'll pass in sort by.
Yeah. Nice. Killing it.
Okay. Do we need to map the enum to anything?
We don't. So that is just going to work for us because it's a list of those strings. So no mapping required.
Okay. So where are we done? Is it ready?
I feel like we're done. Yeah.
Let's see what happens.
Let's check it out.
Here we go. Okay. Man, camera, and then the sort by is SKU or name, and because it's an enum, it shows us what's available. So let's go by name. Cool. And I have to set fields. So then we're gonna get back SKU, name, sale price, and description. Oh no, cannot return null for camera description. Okay, let's just get rid of that.
Yeah. I feel like that was a recently deprecated thing that's messing me up.
Look at that. So now we have a $2,500 camera. GraphQL's got expensive taste. Okay. And then, so for the TV, we can just reuse this data source, right?
Yeah, exactly. So it's so cool because you know how long that link is. That's too long. And so if we build that one time, then we know exactly where to go to start making some changes. So what we'll do here is, you'll just create another one of those for getting a TV. Yeah.
Oops.
Love it.
And then this needs to change, I assume.
Yeah. So this one it'll just say TVs.
Perfect.
There we go.
Okay.
Yeah, I don't think anything else changes.
All right.
Because that URL is so similar, we could probably do something more reusable with that, but that's okay.
Definitely could, but we won't. And so then here I'm going to do the same thing. TV, we can keep this sort category and we'll return a TV. Okay. Then, assuming all has gone well, I'm going to swap this out for a TV. And I broke something. Non-nullable query TV. Did I forget to add it to the query? No.
Let's take a look.
Okay, so we've got TV, sort by, sort category.
Did we create the TV type?
Got the TV type, SKU, name, sale price, description. We've got, I didn't.
Oh yeah.
Okay.
That pesky resolver. But that's kind of nice about GraphQL. It's always going to let us know. It's that type system. So it doesn't have data because we didn't ask for it.
Look at it go. Okay, there we go.
Yeehaw.
Also, that TV is very affordable.
Yeah, wildly different.
What is up?
Tastes in TVs and cameras for this app.
This app is apparently a hipster living in Portland who's like, I'm a photographer, but I don't watch TV.
I don't even really have a TV. It's not really part of my lifestyle. I mostly read. Yeah, that's awesome. That's working. So yeah, the data source gives us this nice little reusable wrapper thing, which is kind of sweet. And as I said, handles things like caching and
Mm-hmm.
things that we would have to build in order to use fetch, which fetch is awesome for many things. But if you are noticing performance hits, you could use something like this.
Yeah. And a thing to point out is the first time we ran this, it probably took maybe like a second to finish, and now subsequent hits are like 200 milliseconds. So it's clearly like you can feel the impact of that. And I actually don't know if the slowdown is coming from this Mongo hit or not. There are tools if you're interested. This is way beyond the scope of what we're doing today, but you can do tracing in GraphQL to the like field level of like how long it took to resolve each field, which is really, really cool and gives you really good visibility into like, if you do have a slow request, you can figure out like, oh yeah, it's the person is slow. So we should look into why that connection is slow or something like that. Which is very hard to do with REST. So yeah.
Yeah. There's also a tool called Apollo Studio, which used to be called, Graph Manager, and used to be called Apollo Engine before that. But if you add that, you basically just add it as a key to your Apollo server, and this will give you metrics for that sort of thing. So that's really cool, because then I can see, okay, we got good performance on camera and TV, but person's slowing us down. So all of that can help out a lot.
So, okay, I think we're done, right? We've got it. Person, woman, man, camera, TV. We remembered everything.
Person, woman, man, camera, TV. We did it.
All right. Look at us. So then I'm going to bring you back to this part. What is parent?
Yeah, so that parent thing, hello, parent. So what that is it's going to allow us to basically look at the parent object. So if that makes no sense, that's totally fine. Let me show you, and then it hopefully will. So the best place to probably demonstrate this is with our women. So we only have an ID, a first name, a last name, and a location here. But what we can do with that URL field, what we can do with that parent is we can add another field. So let me show you what this looks like. So for example, the woman, right? If you wanted to add a URL for a string that returns a string to the woman.
Oh, sorry. You wanted me to do that. I was just watching.
I was like, I'm supposed to let you type, and then I just take over. And I do that at class too. When I'm allowed to be at class with people, I use their computer, and then I apologize to them. So yeah, I can type the rest. So the URL here, we've added a field for string. We don't have that anywhere in our database at all.
Right.
But that's okay, because we can use that parent to help us out with that. So let me show you what I mean. Down here in our resolver map, we have our woman. So that's related to the query. But let's add a resolver for woman. And I want to make sure that I'm in the right spot. So we're outside of the query resolvers object, and we can
like collapse this entirely just to show that these are side by side here.
Yes, we'll be legit and collapse it. Cool. That's not the right button to click. Yikes. Cool. So I'm just going to scroll down, and because I don't know what computers are, and this time for woman, we're going to add a field called URL. URL returned a string, right? So it could just return a regular old string. So, hey, I'm a URL.
And this is really, okay, so we're about to touch on something that I think is one of the coolest features of GraphQL. So let me refresh the page here, and let's get this URL.
Yeah, do me a solid and grab that field.
So here we are. We're getting a URL. And so that may feel like magic, what just happened, but check this out. So here's what's happening when we are making these queries. When we return this person, what it's doing is it's taking the object of the person and it's saying, in the person object, look for fields with these properties. And if you find them, return them, right? So effectively, all that's doing is like, if we were to look at what a resolver for a woman looks like, we've got the first. It would just be first, and then we get that parent, right? And then it would just be parent.first. Am I correct in this?
Yeah, absolutely.
Oh, it's beautiful. It's beautiful.
So nice.
But GraphQL does that for us, so we don't have to do that work. Okay,
yeah, exactly.
I'll let you take back over again now that I'm done.
No,
Sorry,
it's so
I got
cool.
carried away. I got so excited.
It's super exciting. I get it. So what we're going to do now is, remember, this can return any string, right? So I could just say slash name.html. That's great and all. Would you mind running that query again for me?
Yep. There.
Cool. So now every time we have that, it's going to add it. And then if we change the ID for the woman, maybe to 3 or 4 or something, it will add that for the URL for that person as well.
Mm-hmm.
So now here's where the parent thing gets fun. So I'm going to pass in parent. Then I'm going to say parent.first.html. So now we're creating kind of a custom URL based on data from the parent object. So every time I ask for that field, every time I query URL, I'm really asking for this function to be called. So the parent allows us to tap into that object. This is a simple example because we're using the JSON file for this, but we should know that every time we want to connect data, anytime we want to set up weird data relationships between different types, we can use this parent object to kind of act as a lookup between the different data types. So a lot of power in this parent object. Sometimes people call it underscore. Sometimes people call it object. I always am in the habit of calling it parent. Sometimes people call it root, but it's all the same thing because the resolvers are recognizing those values by position.
Yeah. And so people are asking in the chat, is it like this or is it by default? Like the way that I always think of resolvers is that when you define a GraphQL schema, you are creating a nested column of like functions, basically. And so when you call the query is a function, and then it looks for this, and then it looks for a function called person in the resolvers. And then for each field that you ask for, it runs a function that matches this field name. And it just passes down whatever the thing is so whatever the result of person was, it's going to pass to name. And if name had subfields, any subfields there would get the result of name. So it just kind of like progressively passes down data so that you can do things like Eve's describing here. It's really, really powerful stuff, and it's really, really nice. And like to show maybe like a really quick example of how this could work. Like if you've got a person, you could do best friend and return a woman. And we could do down here under person, we can add a new resolver for person, and it would be best friend. And this would be like, you can do something like this. Like we can return women.find, or actually, why don't we just do this? We'll do like women 3. And now if we refresh, assuming I didn't typo anything, we can do best friend. And under here, we can actually get details about the woman, which is amazing, right? So your best friend is this woman. And if we change the reference, then we get a different best friend. And so this is really, really powerful stuff because now we've got a link between data. Like this and this are coming from 2 completely different places, but because we have access to the underlying JavaScript and like the way that data is linked up, we can just make these relationships. And that is super powerful.
Yeah, that's the graph part, right?
Mm-hmm.
The graph part of GraphQL, where we have all these different data types that we connect. I love that example. That's great.
So, okay. I think this is our stopping point. We're just about out of time. So if someone wants to go and learn more, where should they go next? Like, what would be a good next step from here?
A good next step would be just to kind of try this out with your own data sources. I think getting hands-on experience with an Apollo server, this kind of represents a few different types of data, but you can use your favorite database and connect up all sorts of different sources. So that's a good next step. Yeah,
I'm also going to recommend go follow Eve on Twitter. And make sure you go check out all of the places where she teaches, because this is just the tip of the iceberg and there's so much to learn, and Eve is such a wonderful teacher. So if GraphQL is something you want to get into, or React, now that you're releasing your React material, like get in there, learn a bunch, go do amazing things with this. Like the doors this is going to unlock for you are unbelievable. Anything else you want to link to, shout out, anything like that?
We do send out a mailing list from time to time. You could go to bit.ly/Moon Highway for that. We post articles on our website as well. Or you can find it on any of one of those articles, a link at the bottom. We do have a really exciting new GraphQL course coming out at the beginning of next year. I can't say too much about it right now, but I will just say that it is very fun, very in-depth, and I can't wait to get it out to you all. So just keep an eye out for those types of announcements.
Super, super exciting. One more shout out to White Coat Captioning for doing the live captioning today. And that is made possible by our sponsors, Netlify, Fauna, Sanity, and Auth0, who all pitched in to make the show more accessible to more people, which means a lot to me, near and dear to my heart. Make sure that you go and check our schedule. We've got, let me go up here. Make sure you go check out the schedule. We've got so much exciting stuff coming up. Next week, we're going to do something that's going to melt my brain. We're going to talk about observability, and this is going to be like low-level server, like how to make sure that things work. And this goes beyond logging, beyond what you may have dealt with before if you've ever tried to keep a production system up. I'm so excited about this because it's an area that I've always wanted to know more about, and I know literally nothing. So Shelby is going to give us just a great introduction to this, show us how to wire it up. We've also got Monica Powell coming on next week, and she's going to teach us about web mention and Next.js. Web mention, if you haven't heard about it, is a way to turn like the whole internet into your comment section, which is really, really interesting. So make sure you tune in for that one and browse through the rest of the schedule, because we've got just incredible stuff coming up. So many amazing people coming on. And the episodes that we had to reschedule last week while I was out of my house have been rescheduled. So Ben is coming back on October 8th and Emma is coming back on October 27th. So make sure you mark your calendars. And with that, I think we're going to call it a wrap. Eve, thank you so, so much for hanging out with us today.
Thank you so much, Jason. This was awesome.
Chat, as always, thank you for hanging out. Stay tuned. We are going to raid, and we will see you next time.